Here we are, force method example 3. Let's keep moving a little bit faster each time we do this. So we're going to find the determinacy. Okay, n equals 1, r equals 4, r is greater than 3n, therefore statically indeterminate to the first. And then 2 is remove redundant support. In this case, B. So what we're going to have here is we're going to have, well, that's a tricky loading. So we're going to take this loading here and we're going to convert it into two other loadings. We're going to have a uniform load here of 2 kip foot plus another loading of 2 kip foot upward where the other one isn't, and these should cancel out to equal this, plus our redundant loading here. Remember, this is real, real, and then redundant. Okay, that's going to displace this downward. This is going to displace this upward. And this is going to displace this upward. Delta B1, delta B2, delta B prime. Now for 3, we're going to do our compatibility equation. Comp EQ. And this is going to mean that B is equal to delta B1 plus delta B2 plus delta B prime equals 0. Or in other words, let's write this really quick because it's going to come down to it. B is equal to delta B1 plus delta B2 plus BY lowercase f BB. Okay, knowing this, what's our delta B1 equal? What's our delta B2 equal? And what does our B prime equal? Well, we know this one's going to be PL cubed over 3, which is going to equal BY over L cubed over 3. With this one, we know this. We should know this one by now. It's going to be WL to the 4th over 8 EI. Of course, since EI is constant, we can just do our little trick that we learned where all we do is we just divide each of these at the end by EI. And then this one's a bit trickier. I'll look this one up right now. This one is in my Discord. Yes, this one's very tricky. This one is going to be 7WL to the 4th over 384. Now, that's assuming this is downward, so this is negative, negative. This one's also assuming it's downward, but this is upward, so that's negative, and that's assuming downward, and it is downward, so that's fine. Now that we have this, what do these actually equal? We're going to have 2, alpha y equals first off, 2 times L, in this case our L here, forgot to notate it, is 8 on each side, so it's going to be 16 altogether to the 4th over 8, which gives us 16,384 here. This is going to give us a negative number, 7 times W, which is 2, times L to the 4th, which is 16 to the 4th, over 384, which is 7168 over 3. which is 2389.33. And then here we're going to have 16 to the third over 3, which is 4096 over 3, which is 1365.33, of course, negative there. And again, just as like a nice shorthand, we can say this plus this divided by this is going to equal our by. Okay, we know this because delta b1 plus delta b2 plus by fbb equals 0. So what we can do is we can move this to the other side. Okay, now that's negative. Equals that. Now we can divide that by our fbb, and there is our by all alone. So we know this works, so from this we can say that by is going to equal this plus this divided by this. Do I have to do that in other steps? I think I might have to do that in steps. This plus this now divided by this. By should be equal to, what is this, 13.75? Let me check really quick. It looks... That looks, let's see. Nope. Okay, something's a little bit wrong here. That's good. That's good. That's good. Oh, plus a negative. That's all. $10.25. Simple mistake. That's all. Just forgot about that. All right. So now we have by. What's our ay? Sum of the forces in y tell us that. That's 2 kip foot times 8 foot. That's 2 times 8, which is 16. It tells us that ay minus 16 plus 10.25 equals 0. Move these to the other side. That's going to be a positive 16 minus 10.25, giving us ay equals 5.75, and I believe this should be in kips. We have by, ay. Does it ask us ax? It does. Sum of the forces in x, ax equals 0. Okay, sweet. That's, again, force method example 3, part 1. This is always the easy part. The hard part of the force method is not the force method. It's finding the moments. So I'll have to do that in part 2. So yeah, there you are.